Alright, in this video I'm going to show you how to set up a data science environment using a couple different methods. So specifically we're going to look at using Google Colab, using Anaconda, using RStudio, and then also VS Code. So we're going to start off here with Google Colab because that's probably the simplest method, and then we'll move on to some other options. Okay, so just some notes about Google Colab before we take a look. Here are some pros. So it's free. It works for Python, and it can also work for R, though we're only going to really look at it for Python. It doesn't require any local installations. It's pretty easy to set up. I mean, there's really not much setup at all. You can share easily with it via Google Drive or through collaboration inside of Google Colab. It can link up with your Google Drive if you have a Google Drive, which you can also get for free, and also you can link it up to GitHub or a GitHub repo. So how Google Colab works is that instead of using your local computer and your local computer's like processor and hardware, you're effectively using Google's server to crunch some numbers for you. So it turns out that Google's servers have some downtime, which means there's some computational like cycles that aren't actually being used. So what Google's doing here is allowing you to basically task their server to do some computation. So that means everything's done remotely, and you don't have to like task your local machine to do it. Some cons for this process is that you're basically limited to working inside of notebooks. So if you're not a big fan of like a Jupyter notebook, then you're kind of stuck in that environment. You can't use just like as much resources as you want. There are limits in terms of the amount of memory you can use, the amount of like CPU usage you can take up. Note also that you can use not just their CPUs, but also their GPUs. So GPU computation, or like on graphics cards, are useful for certain types of analyses. So one example is like doing deep learning with neural networks or convolutional neural networks. Those type of processes tend to be really slow on the CPU, so you pretty much have to have a GPU. So if you're doing some simple experimentation or trying to learn how to do those types of things, it's nice because you don't have to buy a GPU, which can be pretty expensive. However, if you want to get into really like hardcore computation where you're going to need to run models a long time, then you may end up having to invest in a local machine or setting up a virtual machine or something. This is also not like a fully functional IDE or integrated development environment. And there are some limitations in terms of having access to like your local files. So we will talk about how you link up to your local files here in a minute. So anyway, that's Google Colab. So let's have a look at Google Colab. So if you want to use Google Colab, you can just search for Google Colab on the web. It should pop up. Note that you're going to have a Google account, which was free. So anyway, you can set that up without cost. When you go in, you'll end up on a drop page like this. You can see it kind of looks like a notebook. So I'm going to start by creating a new notebook. So I'm going to go File, New Notebook. And we're going to name it here. So this works a lot like other like Google software, like Google Slides, Google Sheets, Google Docs. So you have a default name here. So I'm going to change this name to Example Notebook. Let's do 5. I can't remember. I know I've done this before. So anyway, so there's our notebook. Alright, so let's look at the layout for a second before we move on. So you can see you're going to add new blocks here, or cells. So you can add code cells, and here's delete and whatnot. And you can also add text cells like for Markdown and whatnot. Okay, so you can add in comments. You can also share your notebook with others, like for collaboration, so that's nice. Alright, so a couple of things you're probably going to need to be able to do. Let me make this a little bit bigger while we're working in it. Okay. You're probably going to want to be able to connect to your own data. So there's a couple ways to do that. If you click on this folder icon here, you can upload a file using this button here, so you can find a local file on your disk and load it effectively into like the memory for the session. So that's one option. Probably a better way to do it though, especially if you're going to use multiple files, is to link up to your Google Drive. And that's actually really easy to do. So click out of here. If you want to link this to your Google Drive, you have to click on this Mount Drive button. And it'll ask you this, hit connect to Google Drive. And then it's going to look for your Google Drive associated with whatever account you're logged into. And then it should set that up. Now you'll probably get a couple messages early on. I already did this, so I didn't get a message, but it'll ask you to like authenticate it if you haven't done that already. Okay, so anyway, there's my Google Drive now, and if I go in here, I can see like my drives and drives that have been shared with me, and then the associated data. So I put on this drive all the data for my my data science methods and open science class. So if I click here, you can see that it is. Let's see where we at here. Let's see if I can find my folder. Here we go, MMO's data. So that's the folder and has all of my data in it. So I'm going to click on, if I right click on this, there's a copy path option. So I'm going to click on that, and I can connect to that folder path. So first off, another nice thing about Google Colab is that it has a lot of the data science environments and libraries and whatnot already set up. So I'm going to do quick here. We'll do we're going to do import. We'll do import NumPy as NP, and then we're going to add other ones. We'll do import pandas as PD. So there's our NumPy and pandas. So if we hit run here, it should import those libraries for us. Okay. Sometimes when you first run, it'll take a minute because it's got to connect and whatnot, but see, it ran there pretty quick. So okay, now let's use pandas to read in one of these files from this path. So we'll do, we'll give it a name. We'll call it seeds1 and equals, and then we'll do PD, so it's pandas, our alias there, dot read CSV. I believe that's the path. Yep, there we go. And then we just need to give it the file path. So, oops, there's all the documentation. Alright, so I dropped that in. Put some quotes around it here, and then the name of that file, I believe, is seeds CSV. Close that off. Let me make sure. Yeah, there we go. Sorry, this is probably a little too big. Let me make this a little smaller. Oops. There we go. Alright, so if we run that, now that got read in. So I'm gonna next, let's just add in another cell here, and we'll just do a print. See the data. So print seeds1 and run. There we go. Just a couple other notes before we move on to the next option. If you want to see your variables, you click here, and it lists the only one I have now is seeds1. You can see its shape. It's in its data types. It's a data frame. It has 210 rows and 8 columns. Again, if you make another object, let's just do like x is equal to 2. Then we should get a new object there. So it's variable x, and it's an integer type. Okay, so anyway, that's to see your variables. This table of contents, if you want to have like multiple documents or break things into pieces and whatnot. Don't really use that too much. Yeah, I think that's pretty much everything that I wanted to share. I guess the last thing just to note is you can save a copy. You can save a copy to your Google Drive or to GitHub if you're linked to GitHub, which I'm not. You can save the current document, which it does it periodically, just like a Google Doc. And you can also download it as a Python or a IPython notebook file. Cool, and then obviously rename and all that stuff. So it works a lot like other Google software tools. Okay, so that's that. So if you were going to use Google Colab for a class, probably the easiest thing to do would be to take the data from your class, put it in your Google Drive, then mount your Google Drive, and then you'd have access to all the data that you need. Okay, so anyway, that is Google Colab. So now, oops, I lost Anaconda. Now we're gonna move on and look at Anaconda. But before, let me move this over here. Okay, so there's some notes about Anaconda. So now we're moving into an environment that's local, meaning you're running it on your own machine. So Anaconda is also free. There's some paid options to give you some more functionality, or if you're working in for a business level. But for individuals, it's free. You can use it for Python and also R, but we're mainly just going to look at Python here. It allows you to create multiple environments. So Anaconda has one component is the Conda package manager, and you can use that to set up multiple environments with different packages and even versions of Python, which is nice. So there's a good bit of customization in that you can set up different environments and package, like sandboxes effectively. Since it's local, on your own machine, you have access to your local files, and you have some multiple ways that you can work. So you can run stuff at the command line. You can use notebooks, either Jupyter Notebook or Jupyter Lab, and even like the Spider IDE, which is kind of integrated in. Some cons are that you have to actually install it on your machine, which means it takes up some space and whatnot. And obviously there's more required setup, and it's a little more complicated than simply jumping into Google Colab. So I'm going to demonstrate here. There's a couple of things, just some notes about the setup, and then we'll just look at how to set up a virtual environment, and then actually use it. Okay, so if you want to download Anaconda, you can get it from the Anaconda website. So if you Google like Anaconda Python, you'll find it, and then you can download an installation file. Software works in Linux builds like Ubuntu, or Linux distros like Ubuntu, Windows, Mac OS. So it's pretty much works anywhere. Let me show you once you download the software, you'll get something that looks like this. So let me open that up. And I'm going to actually run this because I already installed it, but I just wanted to show you a couple things. All right, so hit next here, agree to the terms. You can install it just for yourself or for everyone. If you install it for everyone, you have to have admin privileges. I'm just set it here to just me. That does impact where it gets installed. So if you do all users, I believe it's out on your C drive, or within the Anaconda folder and the program files. I can't remember. If it's just me, it's going to be under your user account. So I'm going to do that. Okay, so you can see it's going to install into that directory there. Let's go back and do all users and see where it installs. There we go. So if we hit next here, again, agree, we'll just do just me. And, I already have that because I had installed this. It's already installed. So let me just put an X on the end here so it doesn't mess up my actual installation. If you're on Windows, you definitely want to click on this add Anaconda to my path variable option. So that just helps with if you're running it from the command line and whatnot. So it definitely click on that. Excuse me. It acts like it's kind of dangerous, but in Windows it makes sense, and it's actually kind of necessary for some use cases. So click on that. And then if you click install, it'll run through the install process. It takes generally 10-20 minutes. Depends on your machine. Okay, so now that we have Anaconda downloaded and installed, let's look at actually setting up an environment. So once it's installed, if you go into your list of programs, you should have it available in an Anaconda folder there. You're going to look a little different if you're on a Linux distro or on Mac OS. Here on Windows, if I go into this folder, I have the Anaconda Navigator, which is kind of like a GUI for setting up environments and looking at the different environments you have and everything. We're not going to look at that. We have Jupyter Notebooks, Spider there. What we're going to do is work on the command prompt. I'm just going to use the PowerShell. If you use the command prompt or PowerShell, it really doesn't matter. And we're going to look at setting up an environment. Okay, so if I open this up, this over here. Okay, so you can see here that we have, it says base. That means we're in our base Python environment, and you can see its location. So what I want to do is actually set up an environment that will have all the stuff we need to do some data science within. So the first thing we're going to need to do is create a environment. So if you do the command Conda and then create and then -n or -name, it doesn't matter. And then we'll do, we'll just call this West Virginia view. So that's this West Virginia view environment. And we'll hit enter. Note that sometimes when you first do this, it'll yell at you if your Conda isn't up to date, and you should generally try to keep it up to date. Mine should be fine because I just installed this like 10 minutes ago, so it should have the newest version. Actually not, it's saying it has, so there is a new version, but it's pretty close. We'll just leave it alone for now, but you could try to run an update if you want. Okay, so now it's telling us it's going to create this new environment, and it's going to put it in this location. So Anaconda 3, environments, West Virginia view. So let's put Y there, and it should create that. Okay, so now we have this environment. Note if you want to see the list of environments on your machine, you can do Conda. I think it's env list. That's correct. And this should list all the environments that are installed. So now it's just searching. Okay, here's the ones that we have. So let me use out here. So basically I have my base environment. The asterisks mean that's the one that's currently active. Here's the one that I just created. And then there's a couple others here that you can see are along a different path, and that's because there are other tools on my computer that are using Python and have their own environments. So these two are coming from ArcGIS Pro, which is a GIS software, and this is coming from R. So we'll talk about R later. But that's what these are from. They're from other environments, and they're on a different path because they were installed differently. This was through R, and this one is through ArcGIS. And then the ones that you install through Anaconda should all show up in the Anaconda 3 folder under environments. Okay, so to actually use an environment, then you first need to activate it. So to activate it, you just do Conda, activate, and then the environment name. So West Virginia view. Okay, and now you can see that the name here has changed from base to West Virginia view. Now to go out of the environment and go back into the default, you can do Conda deactivate. And I actually don't think you have to put the environment name, but you can. And now you can see it kicked us back to base. But I want to be in West Virginia view, so I'm going to rerun the activate. So I'm just clicking my up key to recall the commands. So we're going to do activate. Okay, cool. So we're back in the environment. If you want to see all the packages that you have installed into this environment, you can just type Conda list. And this is a brand new environment, so you can see there's nothing in there at all. Okay, so that's that. So if you want to set up a data science environment, there's going to be some tools or packages that you need. So you're definitely going to need like NumPy and pandas and whatnot. So we're going to try to set all that stuff up. So just as an example, if you go into the websites for different tools, let's over here. Here's NumPy. It should give you info about installation. So if you go to install here, it'll give you some commands. What we're going to try to do is use Conda to do all of our installs. So first thing, I want to make sure I have this Conda Forge channel available. So I'm going to drop this in, and we'll run that, and then we'll go through our install process. So I'm just doing a Control V here to drop that in. Okay, so now I should have that channel. Okay, so I'm going to try to install into this environment everything I need kind of at once. So to install stuff, we want to do Conda install. And then we list out what we want to install. So we're going to need NumPy. And this just spaces between each package. You don't have to put colons or semicolons or commas or anything. So we need NumPy, we need pandas, we need matplotlib, we need Seaborn, which is another graphing library. We probably want SciPy and then scikit-learn. And expand this out a bit. And let's do Jupyter Lab. Believe that's all ran together. Let me check because I'm not sure. So I'm just going to go to the Jupyter Lab website here, Jupyter Lab, and see. There we go. And install. So yeah, it's just Jupyter Lab. And then lastly, we'll run Spider, or set up or install Spider. Okay, so sometimes this will take a while, just so you know. Depends on what you're installing and how many dependencies there are and whatnot. Note that you can also specify the version of Python that you're using. So we could do like, you know, Python is equal to like 3.8 or whatever. Here it's probably going to use the default, which I believe is 3.8, if I'm not sure. So let's just go ahead and put that in. We'll just do 3.8 and see what it does. Okay, that should work. So let's hit enter and see. Actually, sorry, I just said that wrong. If I wanted to specify the Python, you actually have to do that whenever you create the environment, not when you're adding packages. So it's already set to whatever the version is. So if you want to be more specific, or you need an older version or something, you would do that when you create the environment. So actually you can't do it now, so it's already set. Okay, so I think that's everything. So let's hit enter and see if we can get this to run. So Conda is a part of it is a package manager. So basically it wants to try to figure out how to create an environment where you can install the package that you need and its dependencies and not have any versioning issues or compatibility issues. So that's what it's trying to do now, is figure out if it can come up with a solution for you. And then if it can't, it'll yell at you, or it'll try some other options. It looks like it was able to here. Oh, actually, still thinking, I guess. So it said it was able to solve the environment. It's telling us we can update, and now it's telling us everything it's going to have to install. So these are all the different packages that it's going to need to install. Okay, so that looks like it's going to work. So let's hit Y and enter, and let it start running its installation. So again, this will take a while, more than likely, because I haven't tried to install a lot of different packages here. A couple notes is if you later on need a new package or something new to run the specific task, you can go back in, activate, and install other packages. Sometimes you'll have issues where you've already set up an environment and you try to install something new and it has some dependency issues or versioning issues and it doesn't work well with something else and it won't be able to solve the environment. In those type of situations, generally the best thing to do is just to create a new environment from scratch and just kind of install everything again. However, I think like with this, these are some fairly base, commonly used packages. So if you had to install a few other packages on top of this later on, it more than likely will work. Just as, again, another quick note, there are some things that are maybe a little bit less, used less often that might be more problematic. For example, I work a lot with GIS or map or like geospatial data, and there are packages specifically for that, and I've had issues installing some of those in the past and not having versioning issues and whatnot. So generally I would have an environment set up maybe just for like base data science. And then I'd create a separate package that has like for like geospatial analysis or something. Yeah, and there's been some other packages or environments that are really specific where I've just created environments just to use those. For example, like I do some work with like Google Earth Engine, and some packages have been wrapped around it. So I'll just create separate packages just for that. Okay, so we're back now. It looks like the install of all of these packages is complete. You can see it's a pretty long list here. So we turned the cursor back, and it said done, and it didn't say there was any errors or anything. So hopefully that means we've got a working environment. Okay, so again, if this environment's already active, so first thing I'm going to do is let's open up Jupyter Notebook. So Jupyter Lab. So to do that, you type in Jupyter, and then Lab. If you're just using a notebook, you type in Jupyter Notebook. Lab just allows you to have multiple notebooks and whatnot open, so it's a little more involved. Okay, so let's see if that works. So this should spin up Jupyter Lab, and it should open up in your default web browser. So I think that's Firefox for me, but it would open up in a different one if you use a different one. Okay, so here we go. There's a bunch of stuff already open from where it was at before. Let me close all this. Okay, so this is Jupyter Lab, and I'm just going to show you a couple quick things, and then we'll move on. So here's the launcher, so you can create a new notebook. You can also just like work at a console. You can create a Markdown file. There's a couple different options here. So you can also navigate your tree here, or your local directory, and then link to existing files. So I'm just going to create a new one from scratch. So if we do Python 3 here. So that opens the notebook up, and that's just, again, if you do, I'm just going to import. Let me see if I can make this text a little bit bigger. So we'll just do a quick import. We'll import, let's do the same thing, NumPy as NP, and then pandas as PD. So if we run that cell, this little asterisk means it's running, and then whenever it's done, it should kick it back. So that ran. There we go. And then that should load in the plots and pandas and NumPy. Okay. So anyway, that's that. Just a couple notes. So this allows you to add in cells, remove cells, copy cells, save the notebook. Right now, it's got a default name. So if I do save here, it'll save it as untitled, but I could also do like a save as, so save notebook as. You can also download the notebook. If you download it, you can download it. You can also export it out to different formats like Markdown or whatnot. Yeah, so that's basically that. So that's set up an environment, and now we are running or using that environment inside of Jupyter Lab, which runs inside of your default web browser. Okay, so I'm going to go ahead and do a shutdown here, and if we go back to it lost the contact with that because we turned it off. Okay, so now we're back here to our terminal. Note that stuff runs in the terminal here, or the console while you're working in Jupyter Notebook. Now lastly, let's just run Spider. So let's click Spider there, and we should be able to run this from the command line. So again, if you want to use this environment you set up after it's set up, you just go into Anaconda, open up the PowerShell or the command prompt, activate the environment. Not sure what happened there, but it is initializing Python over here on my other screen. Yeah, anyway, you should be able to just go in, activate it, and then run the commands to set it up. So anyway, this is what Spider looks like. So it's a more involved IDE. We're not really going to work with this in my class, but I did just want to show you. I actually really like it. You can run like all your code, sections of your code. There's locations here where it creates your plots and shows you your files and the variables that have been defined and everything. You can do save as, saving copies. So it's a much more involved integrated development environment than just like working in a notebook. So if you're doing a lot of development, it's probably worth looking at one of these more involved IDEs. Okay, so just to wrap up here, let me just show you again. So I'm going to do, so let's say that I'm going to deactivate this. We're going to do Conda deactivate. Okay, back to base. I'm just going to shut this off. So to start from scratch, if you want to now use your environment that you've got set up, you can just go into the Anaconda folder there, click on the PowerShell or the prompt. I'm just going to click on PowerShell, and then that'll launch. And then we want to do, we want to activate it, so we'll Conda activate. And we want to activate West Virginia view, and then that should activate. Oops, something I did wrong. Oh, I forgot the V. So it's basically telling us there's no such environment. West Virginia view. Okay, and then to actually run like the notebook or something, we would do Jupyter Lab, and then that'll activate Jupyter Lab within that environment, which means all of your packages and stuff will be available. So here's Jupyter Lab activating again. Okay, cool. So anyway, that's that. So the next option we're going to look at is more for R, but you can also run Python in this environment too. So let me go ahead and shut this off. All right, so our next tool we're going to look at is RStudio. So RStudio was kind of originally developed by the RStudio group, and it was designed to be an IDE for R. But it's been expanded so you can actually run Python within RStudio. It's actually pretty robust. So some notes about RStudio is that it is free. There are versions you have to pay for, like if you want to use like a server version or like a corporate or commercial license, but for individual use, it's free. Again, it was originally developed for R, but you can use Python within it also, and I'll show you how to set that up. There's a good bit of customization in terms of like, adding and installing packages, changing the interface, whatnot. You can interact with different types of files. So there's like .r files, which are effectively text files, R Markdown files, notebook files, and then .py files. So there's a bunch of options. There's a good bit of documentation. There's a lot of online help. And you can even like set up a link to a GitHub repo with a project, and then actually put in commits and push them and whatnot. Some cons is you do have to install it on your local machines, and there's some setup required. And if you're going to use it for Python, there's a little bit of extra work you got to do to make sure you're working inside of the correct or an appropriate like environment. Okay, so first off, if you're going to install RStudio, you're probably going to want to have R installed first. You generally want to install R from CRAN, so directly. So if you Google R CRAN, let me just open that up here. This is the R CRAN site. You can download it for your operating system. So here's Windows, and then generally you'll just do base or install R for the first time, and then you can download R. So currently it's in version 4.2.1 at the time of that I was making this video. So you download it, you run the executable, and then you have R installed. Once you install R on your machine, you'll have an R folder in your list there. So here's my R folder, and actually a couple different versions. But if I open up the most recent one here, 4.1.3, this is what R looks like. So as you see, it's nothing super exciting. It's not a very slick interface. So most of the time, like I rarely ever just open R for any reason. Instead, I access it through an IDE, and specifically, I use RStudio, which I like a lot. So we're going to close this down, and we will go ahead and install RStudio. So let's search for RStudio. Here we go. It's one word. I put in 2 words, so I knew what I was doing. Just as a side note, the RStudio group or company are recently renamed themselves Deposit. So this may look a little bit different in the future. So anyway, we go here to Products, RStudio. Then we want the desktop, and Open Source Edition. This is the one we have to pay for. So we just want this one. So we do download RStudio Desktop. And then you can see there's a couple options here, and we just want the free version. So if you click on this download here, you'll download and install RStudio. It's generally pretty painless. Okay, so I'm just going to start off here with a quick tour of RStudio with a focus on actually using it for R as opposed to Python. And we'll look at the Python implementation components at the end here. Okay, so this is RStudio, and I have loaded up a project that I already had developed. So just a quick kind of overlay of the console and the IDE and the GUI here. So this area is generally where your scripts will be displayed. You can move stuff around, but this is the default layout. So there's different types of files that you can open and work with in terms of executing R code. So this is what I have here is a .r file, which is effectively just a text file. And all you really do with this is write code, and you can also like add comments, but it's not like a cell based method like a notebook. There are other types of files that you can work with and open. So for example, if you go up here to File, New File, you can see all kinds of options here. So there are options for our notebooks, which are similar to Jupyter Notebooks, where you have cells that can hold code, and you can also have like Markdown and whatnot. And then our Markdown files allow you to include both code and Markdown, which is basically text that can be formatted. And those can actually be rendered out into like web pages and PDFs and Word documents and whatnot. That's actually how I create all the web pages for my R courses. We're not really going to look at anything else here, but just as a couple side notes, Shiny web apps are for making like web dashboards. Shiny's a R package that allows for generating dashboards. You can see there's some options here for creating C and C++ files, some HTML and CSS files, and then down here we have Python scripts, SQL for like structured query language, and a couple other R related documents. So anyway, there's lots of different files. Mainly I work with R scripts and R Markdown files, and notebooks are also good. I just don't tend to use them as much. Okay, so anyway, all those types of files will show up here. And then down here you have your console. So this is where the code is actually like executed. So this is where your cursor is. So when you run something, you'll get a little stop sign here as it runs. If it's something really simple, it'll run so quickly you won't even notice. But obviously if you have a more involved process that might take a little longer, like 10 minutes or half an hour or an entire day, then it'll sit there with the stop sign until it's done. And then here in the other tab you have the terminal. Okay, so that's that stuff. Over here, under environments, you have listed all of your variables. So in this document I have some data loaded in, so like this is a data frame. So things that will show up here will be things like your data frames, your vectors, your matrices, your defined functions, so on and so forth. You also have a history here of commands that were run, which is nice if you want to rerun something or like document the code that you ran. This is connections if you want to make connections to like data and whatnot. I don't generally use that. And then some tutorials. And then down here we have the files that are in the Active Directory. If you generate any plots, they'll show up here. This is a list of packages that are installed. I have a lot installed, so it'll probably take a second to run. And then you also can get some help here. That's pretty much it. These are I don't generally use these other ones. So main thing is packages, or that I use down in this area is plots and files and help. Anyway, so that's kind of the layout. Just a couple notes on the menus. So RStudio has really good documentation. So if you go into help, you can go in here and look for help. There's also links to a lot of cheat sheets for different tools. So for example, these will open in a web browser. This is a cheat sheet for ggplot2, which is for graphing. So these are very nice, concise sheets that help you figure out how to use some key packages. And a lot of the tidyverse packages are included within here in terms of their cheat sheets. Okay, that's that. Under tools, just a couple options there. If you go into global options, under general, this points to the version of R that you're using. If you have multiple versions installed and for a reason, like if you're developing a package or something, you might have to switch between them. That's the main thing that I changed there. Under appearance, you can change the theme to, there's a ton of different themes for the GUI. You can also increase the font size for the text or even the font itself. There's even some different layouts here. So like for example, if I could bump this up a little, you can see all the font increased in size there. If you are going to use this for Python, there's some options down here. So you can select a Python interpreter that you want to use. So if you have different environments set up, you can pick an environment to work with. You can also do things like link to a GitHub repo if you want to be able to like pull and push and set commits and whatnot for on a project. Okay, so that's the bulk of that. Couple other quick things just to note is if you need to like restart R inside of RStudio, if you go under session, there's tools there to terminate R and restart R. Under code, one thing that's helpful is to under edit, you can clear your console. If you've got a lot of stuff in your console down here, you can clear it. It doesn't delete it, it just doesn't show it anymore. It'll still be in your history. But that can be helpful if you just want to clean up your workspace. Okay, and then under file here, there are options for, again, creating new files, opening files, saving things, saving copies, your standard stuff, quitting your R session, new project. Okay, so when to create a new project, you can use the existing directory. If you do this with version control, you can link up to a GitHub repo. So I'm going to do new directory. New project. Note there's some defaults for some different types of projects. So if you're going to build a Shiny app, there's a default there. If you're going to build your own R package, there's a default. There's some options here with like for C, where if you're going to integrate like C++ and whatnot. So I'm going to do just a new project, blank project. And this is the directory that's going to live in. So I'm just going to make a new directory here. Just call it example R-proj. And we'll call this example proj 1. I don't know. Okay, cool. And then note here, if you click on this, you can actually create a Git repo. If you want to do like version control. But we won't worry about that for this case. So I'm just going to hit create project. And then this should initiate a new project. Okay, so now let's say that now you can see now there's nothing here. There's no files or variables or anything. So if I want to create some new documents inside of the project, I can go up here to File, New File, and then like here's an R script, and it just loads an Untitled one. If you click on Save, it'll have you actually save that, and you can see it defaults into the directory that the project's in. So we'll just call this my script. Okay, so there we have, I spelled script wrong. Let me say that again. So there we go. And then if I wanted some other types of documents, I'm just going to show you a few other things. So if I wanted to do a Markdown file, we can do R Markdown. And give it a name, my R Markdown, and it already has an author and a date, and then the type of file that you want to create. Note that there's options here for Shiny apps, presentations. We're just going to do a document. We're set up so it's like it would be for like an HTML web page, and then it gives you a default Markdown file here with a header, some settings, some Markdown text with the formatting, so like the two hashtags as a second level header, for example. This is bold, whatnot, and then send some R code that's embedded inside of these functions, and you can run them here. Okay, so that's an R script. Again, if we do save there, I didn't save. Call this my R Markdown. And then just as another side note, you can do a notebook. So we'll do File, New, and then our notebook. And this sets up a notebook, which again, I don't use these too often. Okay, and then if we do a, oh, that's already saved, but if we do a save there, then we'll have this project that we can go into, and it's going to save all of our scripts and our variables and everything. You can, obviously just work inside of it. If you're going to work in R, I would highly recommend actually setting up a project as opposed to just going in and just writing scripts. It's nice because everything's in one place and whatnot. It's just a better way to work. Okay, so now we're going to look at how you can use RStudio to run Python scripts. I personally really like this because I work a lot in R, so I'm just familiar with RStudio, and it's also just nice to have an environment where I have both my R and my Python scripts all available in the same working space. If you're not super familiar with R, this may not be the best option. However, I do think RStudio is a good IDE even for Python. So I highly recommend looking at this if you have time. Okay, so now, so the first thing, if you want to run Python in R, you need to install the package Reticulate, and that's effectively what allows you to run your Python code within this environment. So to install a package, you just go to Tools, Install Packages, and then search for the package. There it is. I don't need to install this, I don't think, because I have it installed. But if you want to install it, or you need to install it, that's how you would do it. You can also do it in code too. So like down here at the console, we can do install.packages, and then list the packages you want to install. So that would also install it. Okay, and then once you have installed a package, then you need to, in order to use it, you need to call it in. So you do that with either a library or require. Generally, you use library. So let me make this a little bit bigger. That's why we're working in here. So we'll bump the size up here a bit. Yeah. So generally use library. Require can also work, but you're supposed to just use that inside a function. So anyway, here I'm calling it in with library. So if I run that, that'll load the Reticulate library. And then you can use Python. But first you have to set up Python. So you need to connect to a Python interpreter. So here's one that I had from before, but this is no longer exists. So I need to change this out. So again, if you've used something like Anaconda to set up your Python, then your environments are generally going to be inside this environments folder. So let's just find that on my machine real quick. So C, and then users, me, Anaconda 3. Don't see here. Oh, there it is. And then environments. And this is the only one that I currently have, West Virginia View. So if I wanted to use this West Virginia View environment, I would just swap this out for that directory. And yeah, and then that should do it. And then this python.exe, that's the Python interpreter inside of that environment. So if I run that, hopefully it won't give me any errors. Then it should be linked up to Python. Okay, so it looks like it linked up, and then to check, you can run this pyconfig function, and it should tell you what you're using. Okay, so yeah, so here's the location of the Python it's using. It looks like it's using Python 3.9. It'll also tell you the version of NumPy that you're running, and the architecture says 64-bit, and the version of NumPy. So it looks like that worked. So now if I wanted to run some Python, I should be able to. So I'm just going to go in here and do new file, and we'll do a new Python script. Okay, let me just save this. We'll do a Say we'll call it example pi. And now this is not an R file, it's a Python file, so we'll do a .py. Okay. Alright, so let's just see if it works. We'll do import. Let's just import some stuff. We'll do numpy as np. And if I run that, should import numpy. Okay, and it looks like it did. Note that when you're running Python down here in the console, it shows the Python symbol up here, and you've got the three greater than signs as opposed to one. That tells you that you're in Python as opposed to inside of R. And then if we run something, we can do. Let's run something here. So we'll do x is equal to 7, and then we'll do print x, just something really simple, and we'll run that. So you can see that now I have this variable x. Now if we go back to an R script now and we want to run R script, I'm just going to do let's see, x is equal to 7 again, and then print x. Now if I try to run that, it'll kick us out of Python, and see you get just back to having the one cursor there. And then you have a different set of environments, because now we're looking at our R environments instead of our Python environments. So you kind of got like two things going on, but it is a little so it can be a little confusing, but it does work pretty seamlessly. Okay, so that's basically it. One thing I did want to note also is if you have a Markdown file, so like here's a Markdown file. If you want to run a Python function Python inside of here, you can do it right alongside of R. You just have to set the code up a little differently. So I'm just going to copy this. We'll get rid of this for now. And I'm going to paste this. And now instead of putting R there, I'm going to put Python. And actually, I'm not going to give it a name. And we'll just kind of do the same thing. We'll do like y is equal to 11. And then print y. Okay, so now if I run this, it should run it as Python. You see that it did there, and it kicked us back over to our Python environments. And if I run this, it'll just run in R. So anyway, you can have a notebook once you've set your Python up in R that has Python code and also R code all in the same place. I guess the final thing I wanted to note was that you can set up your own like environment inside of RStudio without having to call to an existing environment that you set up with like Anaconda or something. I generally prefer to just set it up with Anaconda just because I'm familiar with that, but you don't have to. So to do that, you can use this function from Reticulate called install mini Conda. And what this is, just so you know, mini Conda is basically kind of a scaled back version of Anaconda. So it's just, a little smaller. So it runs, it kind of runs without all the other bells and whistles. So if you run this, it should create an installation of mini Conda. Oh, actually it looks like I already have that installed, which is fine. So anyway, it's already installed. So let's just go through the process real quick of like making a new environment with mini Conda. So to do that, again, we have to have Reticulate loaded in, and we will just do Conda create. So this is a function from mini Conda, and then we'll just call this environment let's call it West Virginia View Mini. I don't know. And then that should set up that environment for us. Okay, so you can see here that we just created this new environment here with the mini Conda. So let's see if we can swap this out, and we'll swap out to this new environment that we created. So I'm going to go into this script here, and I'm just going to swap this out with the new one, and that should allow us to change our Python that we're using. Sometimes this will fail. Yeah. So if you try to run this. So since I'm just going to restart my R session. Sometimes that helps. Oh, there we go. And let's see if it works now. Oh, I have to run, reinitialize reticulate. There we go. And then run this. So again, we're just connecting to a different environment now. And then let's make sure it worked. There we go. So now you can see we're in a different environment here. One thing to note is it didn't find NumPy because we haven't installed NumPy yet. So we still need to install some packages into this. So to do that, again, you can just use some of these functions from Reticulate. So to do an install, we can do Conda install, and you give it the name of the environment that you want to install into, so West Virginia View Mini, and then the package that you want to install, so we're going to do NumPy, and that should allow you to install a package. Okay, so I think that worked now, so let's just see. So we're going to do, again, our py-config. Okay, there we go. So here you can see now that we have NumPy installed. And if you need to install other packages, for your data science stuff like pandas, matplotlib, you go through the same process here and install those packages until you have a environment set up within Miniconda that has everything that you need. Just a couple other just the examples. You should be able to do things like get your list of environments. So if we do Conda list, that'll list all the environments that it finds. So here you can see some of the environments that I created using Anaconda, and then we have some environments here that were created using R Miniconda, and then the environments that are associated with ArcGIS. So it's just basically finding all the Python environments that are installed on my computer. Okay, so that's basically it. So that's an example of using RStudio both as an IDE for R and also as an IDE for Python. I think it's my preferred method, but I'm a little biased because I started learning in R, so I really like RStudio. But again, I think it is a good option even if you're just using it for Python and you're not really using R at all. But that's just my opinion. Okay, so as the last example here, we're going to look at VS Code. So VS Code is kind of a general coding environment, plain text editor, or IDE, for different coding languages. So you can use it for Python, for R, for like SQL, and like C and C++. So lots of different languages. It actually develops from some other technologies and tools such as brackets, and it's currently maintained by Microsoft, even though it is free. So one group of people that specifically might like VS Code are people that are already coming out of a coding or computer science environment and are like just used to having some traditional like code editors or IDEs to work within. So some pros with VS Code is that it is free. It works for Python and also R, though I think RStudio is a better option currently if you're working in R specifically. There's tons of extensions for VS Code to help it be better at certain things, like for doing like web development, for example, or writing Markdown files or whatnot. So there are already packages set up for Python and like Jupyter Notebooks that you can install, so you can run them within that environment. Again, lots of different languages can be used within VS Code, which is nice. I have found it to be really good for web development. So if you're going to write like HTML files or CSS or like JavaScript, it's kind of my go-to tool for web development. And there's, again, lots of extensions that create additional functionality. Some cons, again, it's local, so you have to install it, so there are some setup required, and there are some additional steps if you want to use it to run a Python scripts. Okay, so if you need to install it, you can just Google VS Code. Find the website there. I had it up a second ago. So if you do a search for VS Code, here we go. Here's the drop page for it. So again, there are builds for Windows, Mac OS, and then Linux distros. So lots of options there. And again, they're all free. Okay, so that's VS Code. And again, the install is really simple. It generally takes only a few minutes to set up. Okay, so once you have VS Code installed, it will show up in your program list. Here's what it looks like. I've got a notebook already loaded in. Before we jump into the notebook, I just wanted to show you a few other things. So there's a lot of additional functionality that you only get by adding in extensions. So to install extensions, you click on this extension button here, and you can search for stuff. So for example, if we search for Python, then you can install Python. So this is the one that I had installed, but it looks like it's deprecated now, meaning that it's being kind of phased out. So it looks like the dominant tool people are using is this one here from Microsoft. So if you run that, that seems to be the preferred method. So if you set that up, that should allow you to use Python within VS Code. Now to use Jupyter Notebooks, you generally also want to install Jupyter. So there's a Jupyter extension. So if you install that, then you can use Jupyter. And there's also some additional things you may want to look at. For example, there's a tool for like managing Python environments and stuff. So anyway, I already have those things installed. Another side note, just while we're in here with extensions, there's also themes. So there are like software extensions and then themes where you can change the color theme. And there's a ton of color themes if you're real particular about that. So there's lots of color themes installs there. If you connect to an entire folder, you can see the content of your folder. Here's for my website. So these are all my HTML files for my website. And then this source control is where you can set up like a GitHub repo, and where you can like push and pull from and add comments and whatnot. Okay, so here is a notebook I opened up that was already created. One thing you got to make sure is that you have to select a Python interpreter to use, and it should see all of the interpreters on your computer. Sometimes I've noticed if I install a new or create a new environment, I have to close VS Code and reopen it to get to actually see it. So anyway, here's all the environments that it's seeing. So here's the here's the West Virginia view environment that I created early in the video, and the mini Conda one that I created in R. So I'm just going to swap over here to the West Virginia view one. It also tells you the version of Python that it's using. Okay, so that's the interpreter. Now, if we start working in here, it should be able to run that code. So a couple notes, the Markdown is actually being showed here as rendered as opposed to the raw data. So if I double click on the cell, you can see this is a first order header. This is some text, and then a numbered list, second order header, third order header, so on and so forth, right? And then here we have a code block. So again, if I would run these, actually I can't because I didn't install all these into that environment. Well, actually I did. Yeah, I did. So those should all be available. So if I hit run here, then it should run those in. Sometimes it takes a second, the first couple blocks that you run, because it's got to, connect to the environment and whatnot. Okay, so we're in those, and here I'm just reading in a data layer, right? Another data layer. So this is all your code blocks. You can see it spits everything out there in the flow of the notebook, just like it does with the regular Jupyter Notebook. So this is effectively just Jupyter Notebook running inside of VS Code. So anyway, I prefer this. Like if I'm just going to run a notebook, I prefer to use this instead of Jupyter Notebook, but that's just my personal preference. And part of that's because I'm used to using this environment for web development, so it just makes sense to me. All right, so if we wanted to make a new file from scratch, one thing I like to do is just make a copy of, well, actually, let's just make something from scratch. We'll do, let's do let's see, new file. And what we want is oh, here we go. I should have switched, I guess, to the version. And then I could do a save as, I guess, and save it out. As an example. Okay. Example notebook. There we go. All right, so again, you can just set up your, your imports here. And I need to swap this back to my other interpreter. So again, it's connecting to the interpreter, so that ran. We can add more code blocks. We can add Markdown. So, and then if you click on the run, there you go, and then it spits it out as its formatted text and whatnot. There you go. So anyway, this is just a quick example of running notebooks in VS Code. So anyway, you basically have to install VS Code, install the Python extension, install the Jupyter Notebook extension, and then connect to one of your environments, and then you should be ready to go. Okay, so this was just a quick overview. Obviously, there are other options in terms of IDEs and environments for working in Python. What I showed you here was using Google Colab, using Anaconda, using RStudio, and then using VS Code. But again, there are some other options. These are the ones that I just have found most useful, especially for doing like data science.